Hi everyone. Today I want to review for a log quiz that we're going to have this week. So let's get started. First question says the asymptote for the graph of y equals 2 to the x minus 3 plus 1. Remember that exponential equations always have horizontal asymptotes. This right here being my horizontal asymptote right there. And so therefore my asymptote is going to be y is equal to 1. The asymptote for the graph of negative log parentheses x plus 2 minus 5. And logarithm equations always have vertical asymptotes. And so the asymptote for this equation is right here. So you've got VA, vertical asymptote, at x equals negative 2. The graph for y equals negative 2 to the x power is decreasing because negative 2 to the x power, 2 to the positive x power does this. This negative sign right here flips it across the x-axis. So now your graph is doing this. But it's continuously decreasing. So that's going to be from negative infinity to infinity. For these problems here, we're going to simplify the following logs, log or exponential expressions. For this problem right here, if base 5 is the same as log base 5, your solution is just x. E to the ln of 4 power would be 4. Keep in mind that, remember, e to any power is, you bring that down front, and that would be log base e. So just keep that in mind. Your e of e becomes 1, and you just have 1 times 4. For this problem right here, again, base b, 3. 1 times 3, 3. ln of e to the 5th power, 5. Because remember, ln of e is 1. That's the same thing as saying log base e of e to the 5th power, and that's just 5. This one right here, we're going to set that equal to x. And remember, this is base 10. So you really have 10 to the x power equals 0.1. Well, 0.1 is 1/10. So that's actually 10 to the x power equals 1 over 10. Now, keep in mind that I can't set my exponents equal to each other unless my bases are the same. So that's 10 to the x power equals 10 to the negative 1 power. Therefore, for this problem, x is equal to negative 1. For this problem, we're also going to set that equal to x. You have 2 to the x power equals the cube root of 2. Keep in mind that the cube root of 2 is actually 2 to the 1, see the 1 right there? 1/3 power, so that equals 2 to the x equals 2 to the 1/3 power. So x is equal to 1/3. For this problem, set that equal to x because there's no variable. You need to set it equal to x. If you're trying to solve a logarithm, these ones are just identities or values that work out where they cancel out. 27 to the x power equals 3. Now, remember, that's 3 to the 1 power. Now, my bases are not the same, so I do need to set them and try to make them the same. So 27 does break down to 9 times 3, which is, again, 3 times 3 times 3. So that becomes 3 to the 3x equals 3 to the 1 power. Bases are the same. You can say 3x equals 1, so x equals 1 over 3. For this problem, we'll set that equal to x, and we're going to have 4 to the x power is equal to 1 over 64. Again, if you're not allowed to use a calculator, you can't log both sides. So what you're going to do is try to get equal bases. So I have a couple options with this problem. One, I can say, well, that's 4 to the x power equals 1 over 4 to the what power? Well, 4 times 4 is 16. 16 times 4 is 64. So that would be 4 to the 3rd power. Well, that's going to bring that up. So I actually have 4 to the x power equals 4 to the negative 3rd power. So therefore, x is equal to negative 3. Another option for this problem right here is right in the top here. I actually could have said that this is 2 to the second power, because 4 can be rewritten as 2 squared. But don't forget your x on top, so that still stays there. And this is 1 over 64 is actually 2 to the 6th power, bringing that up to get them on with the same bases. So I have 2 to the x equals 2 to the negative 6th power, and therefore 2x equals negative 6, so x equals negative 3. Again, option, you just have options with that. ln of 1, well, that equals 0. Let's see here. This one, we'll set that equal to x. We have base, which is 10, so we'd go 10 to the x power equals the square root of 10. Keep in mind the square root of 10 is 10 to the 1/2 power. So that's 10 to the x equals 10 to the 1/2 power. So x equals 1/2. Okay. For these two problems, you are to label 2 points. And in doing that, let's see if I can zoom out again. Zoom, 100%. There we go. Okay, so I would always recommend that you start graphing the parent graph. So for this problem right here, you actually have y equals 1/4 to the x power. That right there is exponential, but it is decreasing. You always should try to graph 2 points. I encourage students to graph 0 and 1. If the x is your exponent, that's your power, then you plug values in for x. If, on the other hand, you have y as your power, then you would plug those values in for y. So plugging in 0, we have 1/4 to the 0 power. Anything to the 0 power is 1. 1/4 to the 1 power is just 1/4. So graphing these 2 points, you have 0, 1, and then you have over 1 and up 1/4. So it looks like my graph, parent graph, is actually doing this, okay? Now, for this problem right here, we have this value here, which is the negative sign, which is in front of my equation. So therefore, that is going to flip it, reflect across my x-axis. So there's that point, and then there's that point. So basically reflecting that across the x-axis does this to my equation. This value right here moves my equation to the right 1 value. So now I'm going to move that to the right 1 value. So all my points are actually shifting over, okay? And so in doing that, now my graph does this. And now adding 2 will take my graph and move it up 2 places, 2 units. So it actually brings it up like that, okay? For this problem right here, my parent graph, again, would be y is equal to, you could just say e to the x power. We know that e is approximately 2.71. So we know the graph of y equals 2 to the x was something like this. And so therefore, you just are plotting these values again. I encourage you to plot 2 points minimum. So you have x and y. And so you've got e to the x power. So x, because x is in my power, I'm going to plot those points 0 and 1. Anything to the 0 power is 1. E to the 1 power is e. E happens to be 2.71. So when I graph this, which I can't see anymore, so let's bring that back up. When I graph this, we have 0, 1, of course. Exponential graphs usually go through 0, 1, to at least to start before you start moving them around. And then you have over 1 and up 2.71. So my graph is doing something like this. Now, with this x plus 1, what that's doing is it's taking my graph and moving it to the left 1 value. So now my graph is going to be going through these 2 points, still going up. And then the -3, what that does for me is it moves my graph vertically down 3 units. Okay, now it's always okay to just plot points. I know sometimes you're going to be asked to plot points. You can choose to plot points within this quantity. So for example, if I wanted to plot any point, like let's say 1. That's not going to be the same as this graph right here because we've altered it. Okay, this is just the parent graph. So when you're asked for a point, you don't give them this point because that's not actually 1, okay, 1/4. So you would plug in 1, you get negative quantity 1/4 to the 1 minus 1 plus 2. Well, this is anything to the 0 power is 1. So this is going to be negative 1 plus 2. So negative 1 plus 2 is 1. So I plugged in 1 and I got 2. So that just moved my graph up. So just so you know, you can always plot these points without, actually doing this parent graph kind of thing too. You can always plot points just by plotting points. So finding the value of the following, let's do some more practice with this. So we're going to set this equal to x. So we would have 4 to the x power equals 1/64. I just did this problem. So this would be 4 to the x power equals 1/4 to the third, or 4 to the negative third. So therefore, x is equal to -3 for this problem. This one, set this equal to x. And we have 27 to the x power equals 3. This is 3 to the 3x power equals 3 to the 1. So we have 3x equals 1, so x equals 1/3. This one right here, again, this also was a repeating value. 10 to the x power equals the square root of 10. That's 10 to the x power equals 10 to the 1/2. So x is equal to 1/2 after the bases are equal. For this value right here, we get just 4x. Ln of e cancel out. It's like log base e, that's this part right here, that becomes log base e of e to the 4x power. You've got 1 times 4x. Same thing with this. You're going to end up just getting 3y. For these two problems, you have write ln of 8 equals 4.162 in exponential form. I don't think that equals that, but let's just write that in exponential form. So when you're writing ln of 8, that's just saying log base e of 8 is equal to 4.162. Now, writing that in exponential form, because all we did so far was we took out the ln and we replaced it with ln, replacing that with log base e. So now what we're going to do is we're going to say, well, that's just e to the 4.162 is equal to 8. And then now it's in exponential form, although I don't think these actually equal each other. Anyway, but that's what you would do, and you would box that up. That's your answer. For this problem here, we want to graph log base 4 of x. So always when you're graphing a log equation that's not a base 10, one of the things that you should do is to set it into an exponential equation. So 4 to the y power is equal to x. Now, as I said before, I always plot points 0 and 1, but if my y is my exponent, I'm going to plot those points here. And so what I have is y here to the 0, so 4 to the 0 power, that's 1, and 4 to the 1 power is 4. So when I actually graph this, I have the point 1, 0, and I have the point 4, 1. So my log equation now has done this. Okay, so that's just log base 4 of x. For these two problems right here, what I would suggest for graphing y equals 10 to the x and its inverse, so y equals 10 to x, I would probably set up my equation where I would plot points. Okay, and so for that equation for x and y, I'm going to plot 0, 1, and I'm going to plot, 0 in here. Y equals 10 to the 0 power. Anything to 0 power is 1. And then I'm going to plot 1. So we have y equals 10 to the 1 power. Well, that's 10. So we have 0, 1, and then we have 1, 10. So this graph is exponential, and it does do this. Well, its inverse, there's two ways we can find the inverse. One way to find the inverse is to reflect it across the y equals x axis, which is that right there. And so we know it's going to do this. But let's say that I actually wanted some points for that. Well, to find the inverse of this equation, remember, you take your x and your y and you switch them out. So really, I have x equals 10 to the y power. And when I have what x equals 10 to the y power, I can plug values in for x and y for that. And again, I would have, if y is my exponent, I would plug in 0 and 1 for that. And so in doing that, when I plug in 0 here, I get 1. When I plug in 1 here, I get 10. So that's going to be 1, 0. And that's going to be over 10 up 1. So this graph is going to look something like this. Now remember, log equations do go to the right. In addition to that, something that you can remember is that, remember when I ask you to find an inverse, you're just flipping 0, 1, 0, 1, 0, 1, 10, 10, 1. So those are just, that's the inverse of those, just a coordinate, a point. So you can always do it that way as well. Lastly, you want to use composition of functions. And actually, when I ask you to use composition of functions, you do need to use that. To see if something is an inverse of each other, you're trying to see if these are inverses of each other. So first of all, let's just look at this equation right here. And I'm going to graph that first. And in graphing that equation, I have a vertical asymptote at -5. So right here, there's a vertical asymptote. And I can plot my y-intercept. So if I set x equal to 0, I have 0, 4/5. So I know my graph actually is going to do this, and I know it's going to do this. So if I wanted the domain for this graph, okay, the domain, I would say that my domain goes from negative, it's always negative, -infinity to -5. There's a break in my graph there, and then union -5 to infinity. And my range would be low to high. So that would be -infinity. See down here, this keeps going down. -infinity, you're going up. My actual horizontal asymptote is at y equals 0. So it does go -infinity to 0 in union with 0 to infinity. So that's my domain and range for f of x, okay? So that's not using composition and function, that's just saying the domain and range for the function. So to use composition of functions, what you do is you're going to take the f of x equation, and I'm going to plug this equation, which is my f inverse equation, inside there. So that's going to be f of f inverse of x. So that's what I'm doing, okay? So let's do that. So we're going to go 4 over x, which is that, which is 4 minus 5x all over x plus 5. Well, this one's a little bit tricky. I noticed that my denominators are not the same. So that is over 1 right now. So I'm actually going to multiply that by x over x. So what I now have is 4 over, I have 4 minus 5x plus 5x all over x, which is then going to become 4 divided by, see this is my divided, 4 divided by this stuff. And remember, when you divide, you're multiplying by the reciprocal. So that's going to be 4 times x over, and then the -5 plus 5x, those cancel out, and I get 4. And what ends up happening here are my 4's actually cancel, and so then that becomes the answer of f inverse x is equal to just x right here. So that's actually what we want. We're very happy that we get that. We have an x. We want an x. For now, not only do I want an x for that, but I need an x when I plug in this equation into the x here. Oh, and here. So for this one, this is a little bit trickier than what I think you're going to see on the quiz, but this is really good practice. So let me write this out, f inverse of f of x, because I'm going to plug the f of x equation into my inverse equation. So what is that? So my inverse equation is 4 minus 5x over x. So it's going to be 4 minus 5 times x. Well, my new x is 4 over x plus 5. 4 over x plus 5. And that's all over and x. And my x is 4 over x plus 5. 4 over x plus 5. So what we're going to do with this problem here is we're going to get a common denominator. So I need a common denominator. So that's going to be x plus 5 over x plus 5. And so my numerator looks like this. 4x, because I'm going to distribute right now. I'm going to distribute. So 4x plus 20, and then just 5 times 4, minus 20, all over x plus 5. Now remember, when you're dividing, you're multiplying by the reciprocal. So I'm going to multiply by the reciprocal, which is x plus 5 over 4. Now, as a quantity, my x plus 5s as a quantity are going to cancel out. 20 minus 20 is 0. That's also going to cancel out. I do now have 4x over 4. My 4s are going to cancel. And so now I have x. So this is equal to f inverse f of x. And so now I've got an x when I plugged in f of x, and I have an x when I plugged in f inverse of x into f of x. So I have both x's. So you can now say, therefore, they are inverses of each other. Yay. Okay, now another thing is that in the original directions, it said, the directions said, use composition of functions to show that they're inverses. Check, we did that. And what is the domain and range of both the original and the inverse? Now, if you recall, the domain and range that we have listed here for my f of x equation, well, the inverse domain and range is going to be its opposites of those. So basically, my domain for my inverse equation is going to be my range. So that would be negative infinity to 0, union 0 to infinity. And my range is going to be my domain, which is negative infinity to negative 5, union negative 5 to infinity. Okay, super. So that concludes the review. Good luck, everybody, on the quiz, and I will see you after break.